Hello, I'm Dominic Hobson, co-founder of Future of Finance. My guest today is Francisco Weber, co-founder and CEO of Cortical, which is trying to move AI technology beyond computational statistics and enable machines to read paperwork and even unstructured emails as natural language. Francisco, thanks for joining us.
Hello, thanks for having me.
Now, the problem your technology addresses is the difficulty machines have in reading unstructured data. Can you tell us how you've solved that problem?
Yeah, so it's all about figuring out what text mainly, which is produced by people, actually means. So much of our business tasks basically is reading a piece of text, might come from an email or within a document, and then understand what's written there and react basically and do whatever's necessary. And that's precisely where our technology comes in and basically helps humans to not only read faster, but also to understand faster and sort of render the businesses more efficient, basically, by being able to ingest more information. Yeah.
So you're not just doing sort of keyword matches, you're actually reading natural language.
Yeah, so absolutely. So matching the occurrence of words is basically the kindergarten version of natural language processing, if you want. That basically comes in historically. That's how we started to figure out what a piece of text means. But nowadays, specifically for all these tasks at hand, which appear in a digital workspace, that's not enough. So it needs really, there needs to be an understanding that Ferrari is actually a red sports car and therefore has a certain number of contexts and plausible items around it. And that cannot be done by just covering long lists of if that word appears, then this could relate to this or that. So that's basically the problem we try to solve with our technology. Yeah.
Now, the word Ferrari is the same in any language, but we as human beings, we speak a great many different natural languages. We speak English, French, German, Spanish, Italian. Is that a problem for your technology?
Well, that's precisely one of the reasons why it's more important to focus on the meaning, because the meaning sort of does not depend on language. So a red sports car in terms of meaning means the same thing if I give it a French name or an English name or a Spanish name. So the point is precisely to go beyond that, what we call the externalization of meaning, which is a specific language which is supposed to encode it properly. Yeah. So in principle, anything that any approach basically that would allow you to understand what is written in an email needs to be independent of language. And it even becomes worse. I mean, nowadays, the standard email, at least let's say in the non-generally English countries, typically has even a mix of languages. So we are supposed to write a German email, but I'm pretty sure in the average email you find like 5 or 10 words, probably in English. And so the whole point is precisely to go beyond the specifics of an encoding, if you want, which would be a language like English. Yeah.
And are you able to translate the languages? In other words, if a team is multilingual, there are some Italian, some Spanish, some French, some English, because they're dealing with clients who speak those languages. Are you able to deliver the content to them in their primary language?
We rather try to avoid this. What we actually want to do is to distill the meaning, and by sort of understanding the meaning, we give the right context. So just imagine, let's say, a person who is not an English speaker needs to search through a collection of contracts, which are all in English. And you know the problem, you have to formulate a proper query to sort of expect to get something useful. And if you need to do that kind of formulation in a language which is not your primary language, you're handicapped. So how much better would it be, let's say if you're a German speaker, to actually say that you formulate your query in German, the system digests out the meaning of what is sort of described in German, and then matches that meaning with the meaning of all the documents which happen to be in English. And once that user gets back those English documents which are relevant, so a human typically figures out fairly quickly if a bunch of documents make sense or not. Yeah, I mean, that's sort of a new skill that has become standard today. So the English, as I said, of this non-native speaker might be enough to actually understand the document, but it's a bit cumbersome maybe to formulate a query accordingly. So being able to cast, in that case, a German query and then get meaningful or contextualized English documents back would be such a case. And there is no point of needing to translate. That's what we have done a couple of years ago, where we have done precisely these kinds of things to either translate the query and then match it. But the problem then is that if you have not properly chosen your terms, they get a bad translation, and as a consequence, you get not so good results back in the search. But if you do the matching at the level of the meaning, you can be sure to actually get the right results.
Mm-hmm. Can you give us a handful of practical examples of industries, companies where your technology has actually been deployed, ideally in the financial services industry?
Yeah, so if you want, basically anyone who does business by using a computer means somehow digital information can make use of our products. But of course, there are specific industries like the financial industry, for example, that have sort of a very big reason, simply for the fact that the products, if you want, are actually language. Yeah. So in fact, a bank or an insurance company, when they sell something, they sell a document basically, which happens to be typically a contract, where the actual profile of the product is described yet again in language. So if you want to have the possibility to interact with your products and to allow your customers to interact with your products in a, I would say, amplified way, amplified in the sense that you get the help of a system to make basically your buying or your selling more efficient, then technology around language becomes relevant at many different levels. And that's basically the reason why we have observed right after sort of exposing our technology to the market a couple of years ago, that precisely the financial industry were sort of suffering the biggest pain in that context, and they were sort of the most early adopters you could imagine in trying to see how that can be used, and that basically led also to our products around contracts in one domain, which is sort of the business transaction and the product related information, but also emails, which is the main way of how people communicate with their bank and their insurance when they communicate in a written form, of course. Yeah.
So you've got banks and insurers using your technology today?
Absolutely. I mean, and of course, this typically starts where you have a lot of repetitive work come in. So, for example, for reviewing large collections of, let's say, credit agreements, I mean, there is a constant change in the regulations. You have constantly to go back and revisit your existing contracts. Do they still comply with the new IRFS regulation and so on? So you actually need someone who is really educated in the domain, because there has to be, of course, some understanding of what the issue is. And on the other hand, you ask those people to actually do highly repetitive work, which a typical human hates basically to do. And so there is precisely the problem that you need to have highly skilled people do repetitive work. And what I keep telling customers when they sort of come into contact with our technology the first time, I say, yes, of course, let's say an experienced attorney in the banking area can review a contract, and you can be sure that you get a close to perfect answer. Yeah. So if it's about finding out what the termination clause is, for example, yeah, so you can expect to get a perfect answer from a human. If you ask the same human to work his way through, I don't know, 100,000 contracts, I can guarantee that the quality that human is able to provide will be dramatically lower. Yeah, so there will be a lot of errors and a lot of sort of inattention issues that come in. So when we often say, how precise is the algorithm? Is it capable of actually replacing in terms of qualifying certain information? Is it able to replace a human? I say, probably not if it comes to handling 1 or 2 contracts a year. But precisely, once you start to have volume, then humans tend rather to be an impediment, sort of. And that's precisely where it makes sense to provide those humans with a tool that takes away basically the boring part of the job and keeps them what is actually needing their precise experience and expertise. Yeah.
The way you're describing it, it makes it sound as if the machine is kind of complementing the work of the human beings, but it's also making it possible for those human beings to do things they couldn't do before, which is like read those 100,000 contracts
exactly.
very quickly. So is what's happening here actually they're able to do, they don't lose their jobs, they're actually able to do more and more interesting work and deliver more value to their company because of the machine?
Absolutely. I mean, that's what tools are about in general. I mean, we are humans are precisely able to create tools to make their lives easier. And that doesn't mean in principle that the job doesn't need to be done anymore. Or that human will not have a job. I think it just makes a difference if you have adequate tooling and machinery for doing your job more professionally. And as we know, as I said, repetitive work is the worst you could ask of a human. I think it has to do with the quality of work also. And if you compare, I don't know, take any consumer product, how that has been produced 100 years ago and how it is produced today, there are still people producing that kind of stuff, but they are doing it differently, less harmful maybe to their health and to their work-life balance and so on. And jobs, I think, historically have been changing all the time. Whenever there was a new sort of technique or tool or whatever in whatever domain came up, it transformed the jobs that were necessary to do, especially in times when the classical machine was not available. Basically, human bodies were used to become machines. Yeah, so I'm not sure if that's the kind of job where you need to be sorry if it doesn't need to be done anymore. I mean, there are so many jobs I would not like to do them because they're just not satisfying as an activity. And I think that's what our tools are supposed to do is to increase the efficiency. It's all the progress, I think, circles around the concept of getting more efficient. uh, basically capturing more sunlight and make use of it. That's basically what the intelligent organisms on this planet are doing.
Mm-hmm. Well, I'm glad you've used the word efficiency. Was listening to you, I was wondering where the cost savings are going to come from. If you've got the same workforce in place, they're actually doing more and more interesting work and maybe higher value work. In the short term, I expect most of the companies you talk to would also like to see some cost savings, like have less people working for them. So where do the cost savings come from, setting aside the value they add?
I think
create. Where do the cost savings come from?
It comes from sort of two aspects. One is, of course, that you can save tiring, repetitive work of people. So you don't need to put people at certain tasks. The other thing is you can actually finally reach a more complete level. I mean, because the truth is, if, for example, a company needs to review 100,000 credit agreements every year to sort of limit the liabilities and the fees they have to pay whenever there is an error in their compliance status, I would say even the most professional large banks, they cannot do 100% of the work truly. What they do is they try to do enough of it so that chances for being fined are sort of managed and so on. So it's in practice, I don't think that automating some of these processes will actually make people lose their job. I think there is a big buffer of tasks that finally can be done by 100% and not like they have been used to do for 60%, and the remaining 40%, let's hope for the best. So every 10 years we get fined because we are probed in precisely those 40%. So that kind of sort of calculation comes in. Yeah, I think it's a highly optimized sort of view of things, of saying that, yeah, the review has been done by people before and now we are automating and we don't need the people anymore. I think reality is we have been using people to do 60% of the work that we should do. And now finally, we can do the 100% with a high degree of quality, probably with the same number of people.
All right, I see. So the benefits include picking up revenue you would have missed in the past, avoiding regulatory fines, and so on.
Yeah, yeah.
I get it. Tell me, how difficult is it for a company to implement, to deploy this technology? Get it from the cloud, or is it an incredibly complex implementation of hooking it up to internal systems and offshore service providers and so on? How easy is it to install?
So our sort of main goal is precisely by leveraging the capabilities of our technology to allow people who are not AI experts to basically take the driving seat and train models. I mean, that sounds sort of a bit contradictory with what normally is seen, where whenever you introduce some AI and some business domain, you have large teams of experts and subject matter experts who need to work together. And what we found is that the practical implementations of functions like this usually suffers that issue that you have to teach a person who is a specialist in AI about some business process by a person who is not a specialist in AI. Yeah? So there is this whole lost of translation issue you have here. And so our goal is basically to have systems where a subject matter expert, for example, a legal expert, financial expert, they can actually directly use their expertise and capture it in models based on data that they work with. Like if they happen to, let's say, review contracts, then we have the system watch them annotate or sort of work through a couple of those contracts. And while the expert does this, the system builds up a model that sort of starts to make suggestion what should be annotated next, and it becomes smarter and smarter as you go. The fundamental difference with what is on the market right now is that our users don't license a machine model like it used to be normally. But they built their own models and they own those models and they can use it and reuse it as much as they want. And they can create a model for whatever they want. So it's not just a one-shot solution for finding out the IRFS compliancy of a contract, sort of the analytics, but you get a system that can do any kind of analysis based on the subject matter experts that you actually have. Yeah.
Is it therefore a native cloud installation, if you like?
No, it's actually very traditional, sort of. It's a piece of software. Yeah. So right. You can have a piece of software that runs on a computer, and if you, for some reason, have decided to have your computers in the cloud, then it runs in the cloud. If you are a more classy enterprise, you might want to have it run on premise on your business servers you have in your infrastructure. So that's the only requirement. And we make use, of course, of today's technology of sort of virtualizing those applications so that you can literally use them out of the box. You have an image of a virtual server that you can implement on any practical server. So it's probably a matter of hours to get up and running.
Okay. And if you're not selling licenses, how do you get paid for?
We do sell licenses, of course, but it's very traditional software licenses that can be sort of put to any IT infrastructure that you might have.
But it's a user-based license, so more people use it.
It depends on the application. So we have sort of three main applications. One is looking into documents and finding specific content in documents. The second one is analyzing and understanding messages like email or tweets or social media comments or so. And the third one is actually searching. Yeah, so most of the companies have repositories of documents, and they need to have an efficient way in locating where that information is. So it depends which of the domains. For the contract side, for example, it's based on the number of contracts you want to manage with the system.
Now, you've spoken of being inspired by neuroscience, and I think that may even be your personal background. I'm interested by that because as I look at the history of AI, I think of people in the 1950s thinking the way to build an intelligent machine was to mimic the human brain. That became a dead end, and in a way, AI died, I suppose, in the 70s and even into the 80s. And then once all this data starts to get digitized and computing power becomes cheaper and cheaper, people rediscover that you can actually get some interesting results by throwing lots of processing power, lots of piles of digital data, and they call it AI. But you know, there are not many AI websites I visit talk about being inspired by neuroscience. That sounds like the previous generation. So tell us a bit more about what you mean by that.
Yeah. So first of all, we are actually not just inspired by neuroscience, but we literally try to implement in the informatics domain what we have learned in the neuroscience domain. So the reason, and you're right by saying that the early AI was precisely aiming to become somehow like the human brain. The problem with this was that in the 50s of the last century, we comparatively knew very little about the brain. So the problem was not so much what has been achieved or not achieved by AI, but the thing we tried to model was basically heavily incomplete. So neuroscience was always sort of split into different kind of approaches. There were the guys who tried to find out how do the neurons actually work. Yeah, so the basic component of the nervous system. Others tried to find out about the connectome. So which neuron is linked up with what other neuron, and very recently only, neuroscientists started to go more in the direction of what I would call information science approach. So how is the brain actually doing the computation given the infrastructure I have there? Because of course I need a physical implementation, let's say, of a processor. And as we know, that's done with neurons. But the actual computation, the math, if you want, is not depending on the neurons in the sense that the neurons happen to be a way of implementing this, which nature had at hand. Yeah, but there is, let's say, the more abstract concept, for example, which was a starting point for our early work. How is the meaning of something actually represented? So in the domain of machine learning, people were mostly thinking in terms of algorithms. What's the formula that I have to pipe my data through that I get something useful? And people did not consider so much the question precisely how is it actually represented? There has to be a place somewhere in my brain where when I hear the word cat, something cattish appears. And when it appears, how does it look like? Out of what kind of signal is it built, and so on? And there has been, especially as I said, in the recent years, a lot of science done around this. So to me, very influential was the work of Jeff Hawkins, who was precisely working in that field on finding out how the neocortex, which is sort of the part of the brain which actually thinks, how does that actually do the information processing? How does it work? And interestingly, we were focusing very strongly on that question of representation of information. Interestingly, if you read up the very early papers in AI, that used to be the big question then. So there are famous scientists who said things like, if someone finds out how information is represented behind language, then that will solve our AI problem, because that's in fact what the big problem is. And the recent sort of popularity came up as we realized that we, on one hand, don't actually know how the word cat is represented in the brain. But whenever we don't know something in science, we start with statistics, okay? And it turned out that statistics also is useful in the context of characterizing language. And yes, language does have a number of statistical aspects, but the problem is you cannot fully describe language by using statistics. And that's precisely that sort of degree of incompleteness that basically makes the language AI systems so poor compared to a 4-year-old real person in contrast. Yeah, so
But
yeah.
But a 4-year-old, as you pointed out, a 4-year-old, you show them a cat, and then they store the pattern cat somewhere in their mind, and you could be any type of cat, a lion, a tiger, a cat chasing Mickey Mouse, whoever it is, and they recognize that as a cat. And so do you feel with the work that you're doing, you're moving towards making machines conscious? Are you tackling what's called the hard problem here?
Well, consciousness in that context is a big concept, of course. I definitely think that working on language and how language works finally will have a contribution to this. I mean, obviously, at least for human consciousness, language plays a role. So I do think that there is a link there, but to be honest, it's not one of our sort of immediate goals, of course. So we would be happy if we could properly simulate a 4-year-old, even with leaving consciousness out. I mean, there are so many really impressive skills that humans have around language, that there will be a lot of use if we start having those aspects covered. And to be honest, I think that language can also become key in actually understanding how the brain works. The structure that language has actually relates to the structure of the brain. So knowing better, for example, how language is handled in the brain will definitely teach us important aspects about actual real cognition and cognition, cognitive capabilities. So I think it can, to some degree, linguistics could become a new branch of brain science, if you want, by going the way back from saying that's something we have understood in language, and we know how language is actually cast in the neocortex, so we can do certain number of derived inferences and so on how things happen to work in the brain. Yeah.
So you can derive meaning from computational statistics. And as a result, you can read natural language words. We, of course, think in words. So from the process of computational statistics applied to words, you can actually start to get some idea of how a conscious brain uses words to
absolutely
expressing to you now.
Absolutely. The shortcomings of statistics, on the other hand, is the problem as we don't specify how things are rendered. We have, by using statistical approaches, to try all possible combinations. Yeah. So the problem of statistics is that you have always huge combinatorial spaces. So if we hear the word cat, we don't know what actually the word means, but statistically, we can look at all the sentences where the word cat appears and what other words came along. And we just make huge tables of all the words that can be close to the word cat, and we derive some form of number of how that distribution is. And that is precisely the problem of statistics, is it's incredibly inefficient. And interestingly, our brain is characterized precisely the other way around, for being highly efficient. And that is basically what we have found out also in practice. It's not the precision, the achievable precision of a AI algorithm that makes it successful or not in the wild, on the market, sort of. It's actually the efficiency. Because one aspect, for example, is that if you create a model, you have to recompute it, test it, refine it, recompute it. If your algorithm is not efficient and computing a model takes a week, there will be far less cycles of refinement that you will be able to do. So even if the algorithm in principle would allow you to achieve, let's say, 95% precision, you never reach that because it would take, I don't know, 300,000 years to actually get there, just by the processing effort you need to do. On another hand, an algorithm that has a potential precision of maybe only 94%, but that takes you only 25 seconds to compute, you will actually achieve those 94%, which in the end will be higher than whatever you could have achieved with a more precise algorithm. And that basically was, I mean, it sounds simple if you hear it now, but if you are in the midst of business and trying to craft a product that has some success, it took quite a while to realize that chasing precision is the wrong strategy in AI. You have to look for high efficiency AI. That's actually key for real world implementations.
I'm getting a very clear idea now of how a relatively inefficient, iterative computational process complements the highly efficient leap to the conclusion human brain. That's why machines and humans work together so successfully. You're expressing that very clearly. One last question, Francisco. which occurs to me, listening to everything you've said, do you feel that your business is positioned somewhere in a transitional stage in the development of AI? And I'll ask you something very specific here, which is that your company is set up to read unstructured documents. What if all data was structured? What if we had a lot of data standards? Would that make your company unnecessary and force you to move on to the next stage of AI? What difference would data standards actually make?
So if you mean structured in terms of
Yeah,
data
data. Yeah.
that is in databases, first of all, you have the other problem. How do you get all that structured information in? Yet again, a use case where you probably will need some machine to help you. Then when we say unstructured, for example, for language that happens just to be written by a human, it's unstructured in terms of not being a database, but it's highly structured if you consider things like grammar, for example. Yeah, and the meaning is actually captured in precisely grammar, syntax, and all these things that relate to linguistic. In the end, we need a representation of the world that is as close as possible to the structure of the real world. That's the actual reference structure. And that structure, we realize, can be so complex that our poor human minds often call it unstructured. But in fact, it's always highly structured. I mean, unstructured information would be like, I don't know, you probably remember in the old times when you started your TV after the hours and you had this kind of snowy, that's actually unstructured data. So I think that we will always need to convert information from one structure to the other in some way, and therefore all the work we do in informatics about figuring out how to do that efficiently will be relevant for quite some time, I think.
Are you saying that all digitized information, as opposed to analog information, is in effect structured in some way?
Yeah, it has been sampled. So once it's sampled, it has at least the structure of your sampling mechanism. But we humans, we can only conceive structured information. If I give you a page full of text that is not respecting any grammatical rule, you probably have a hard time figuring out what's written there. So the point is, we have to adapt the machines to the structures that are there in data actually, and not try to translate the real world in something like a highly simplistic structure of a database record. Yeah.
I'd love to throw your machine at the novels of James Joyce or episodes of The Wire to put to the test that all language is structured in a way that's understandable. Anyway, Francisco Weber, it's been a fascinating conversation. Thank you very much for joining us.
Thanks for having me.